Two-factor authentication. We're going to talk about that. That's what 2FA stands for, two-factor authentication. Yes, that way around. I'm going to posit as a fundamental fact that your users' passwords are going to be leaked. It might not even be your fault, because you might not lose your database. Some other company might lose their database. Your users aren't very good at using different passwords on different websites. It's really, really common to use the same password across multiple websites. Hence, your users' passwords will get leaked. I'm not going to like this. I'm not going to like this remote at all. Okay, so here's a set of companies that have lost their passwords over the last sort of 5-6 years. Some of them you've heard of, most of them you've heard of, some of them you won't have heard of. There's a lot of engineering resources going on inside these companies, and they are losing passwords. Passwords are not a particularly secure way to hold, the only way to prevent people getting into a website, any way to secure a website. So how long does it take to crack a password once you've got the database? 14 minutes, roughly. That's for bcrypt, the best hashing algorithm we use. MD5 is so fast that you can't get your clicker going on the stopwatch. MD5 is ridiculously quick. SHA-1 takes somewhere in the region of 30 seconds to a minute to crack the average user's password. Because the average user's password is an English word with some letters in the way. Letters change for numbers, you know, where we think we're being really cool and change the E to a 3. For the average brute force password guesser, makes no odds whatsoever. The only way to prevent your password getting brute force hacked is to make it really long with lots of entropy, which is why the password manager, most users can't be asked. It's fact of life. So two-factor authentication exists to protect your users from themselves. That's what it's there for. Once their password gets compromised because they can't actually pick a good password, two-factor authentication will provide another barrier, another prevention of the access to the given website or whatever. So what is 2FA? This is the most common picture, most common example you can come up with. 2FA, two factors, two pieces of information, what you have and what you know. So in the case of the bank example, the ATM, what you have is the card. Can't get money out of a machine without the card. That's one factor. Next factor, what do you know? You have to know the PIN number. So two-factor authentication, one card, one PIN. How do we do it on the website? This is Gandhi.net, which you may or may not have heard of. But they're my current domain supplier. I log in to Gandhi.net, I enter my username, I enter my password. So that is what I know. And then they ask me for a two-factor authentication code, and I have to enter a number. I get that number from a device. So it normally comes from my phone. There's an app on my phone, gives me a number, I type it in there, and I'm allowed into the website. That's all two-factor authentication is. Not particularly difficult. How do we get that code to our server? First way, we could use email. Don't use email. Email is a terrible way to do it, but Steam uses email. It's not the only way now, but it was the only way Steam did 2FA for an awful long while. It fails for a number of reasons. Most obvious ones being spam, delivery problems. It's very, very difficult to reliably get an email. Has an advantage though, very, very wide adoption. Everyone has got an email address. Don't use it anyway. SMS, this is quite a common solution. So what we do here is Twitter and LinkedIn use it. We send an SMS, it goes to your phone, the thing you have on you, you can then type the number in. Main problems are SMS can be delayed. That's getting better nowadays. Certainly in the last 2 or 3 years, the time for Twilio to send you an SMS has got faster as the systems have got better at doing this. And you've got the problem of offline and not having signal to deal with. That is the biggest disadvantage. If you're abroad, you might have to pay for your SMSs to be received. You might not have them enabled when you're abroad. When you're in a tunnel on the train, well, you don't even have to be on a tunnel on the trains around the UK. You just can't get a signal. So there's that potential problem as well. Physical devices. Banks, you like these ones. Blizzard likes this one. This is the other option for Blizzard. So they will sell you a little gizmo, and the little gizmo gives you a card. Gives you a code. There's a number of different types for this. This one down here was the original ones. You just press a button, a number comes up on the screen, you just type it in. I used to really like this one. That was my old system at my bank. This is the new one at the bank. The new one at the bank, I have to type a number in first, and then I get the code out. They work really well in terms of longevity. The battery is never going to run out on you, so that's quite cool. So, slight problem that there's only one of them and you can get it lost. That's always my biggest fear. I'm going to lose the gizmo. The fundamental problem is they're expensive. Realistically, banks can afford it. Blizzard can afford to charge their players to buy one of the little gizmos because the players who play something like World of Warcraft are amazingly motivated not to lose their accounts. Right. You are never ever going to persuade me to purchase a gizmo to access your website. Not unless you happen to hold my money. Then maybe I'll think about it. But realistically, it doesn't work for most websites. Which brings us to an app. I'm assuming pretty much all of you have heard of Google Authenticator. It's by far the most common way of doing 2FA on app devices. Other apps do their own thing. Facebook is built into their app, for instance. So you try to log onto the web, the Facebook app will give you the code. App will do something really weird. The app numbers magically turn up on devices for no apparent rhyme or reason. But generally, we all use something called Google Authenticator or a variation of that, or make a good one as well. App is free, the app is trusted. The really cool thing about Google Authenticator is it's open source. So it's nicely packaged up and everything, but you can actually inspect the source code yourself. None of you have done that. No one has ever put their hand up and contradicted me on that statement. One day it's going to happen, but not today. But we don't have to do that. The whole point of open source is that people who are brighter than us, who are cleverer than us, who care more than us, will have done that for us. If there was a backdoor in Google Authenticator's source code, it would have been found and publicized by now because the source code is free and available. So that's how we get the code to the person. That was quite clear, quite easy, not a problem. What about the actual number itself? That number isn't random, well, not completely random, more accurately, because we have to be able to compare what we type and get on our phone with what ends up on the server. So we have to do some sort of checks and some sort of comparison, hence we need to be able to reliably generate it. And we call these one-time passwords, and therefore we call it the one-time password algorithm. So, OTP, this is the acronym we're going to use from this point on. And I'm going to go through the two most common OTP algorithms that we can actually use for doing two-factor authentication. First one is called HOTP. The H stands for HVAC. It's an RFC. This is another thing about cryptography and about security. Where possible, let people brighter than you invent the algorithm. So this one was RFC 4226. It's a one-time password. It uses a shared secret and a counter. So it is used by the hardware devices that you get from your bank or from Blizzard. Every time you press a button, you get a new number. Press a button again, get a new number. Quite a simple system. Type that number in, go to the website, virtually press a button to increment the counter, compare the two numbers, and we're in. This is what the algorithm looks like. We have a secret. Your secret will not be test. But test is a nice short word, so it fits on screen. And we have our counter, 3, 4, 5, 6, just a simple number that increments. We've got plenty of numbers in the world. We're not going to run out of them. We put it into this HMAC SHA1 algorithm, and we'll get a hash. HMAC is some sort of cryptographic thing. I have got no idea how it works. I read the RFC and just glazed over on that part. I'm assured it is mathematically sound. Again, no one is contradicting me. This is good. So now we've got a hash. That's a really long number. Realistically, nobody wants to type in a number that long every time they log into a website. So we need to convert that into a 6-digit number. How do we do that? We do something really weird. We find the lower 4 bits of the last byte, which is the A at the end there. So we find the last A, and that number is a number between 0 and 15, because it's hexadecimal. From that number, we use it as an offset into our original hash. So there's our original hash. Give the offset, A is 10, and then we find the set of bytes, 4 bytes, that start at that offset. So in this case, it is F5, B0, etc. Mask the top bit, because it's slightly too large for a 6-digit number, and you end up with this number here. Actually, no, you don't mask the bit for that. You mask the bit to stop it going negative. Mask the top bit to make it stop going negative, and then take the last 6 digits. That's how they generate those numbers. Turns out this is really, really easy to do. You can do it in PHP in 15 lines of code, including writing the function. The actual code is 3 to 12. So this is how you do it in PHP. One of the nice things about PHP is that there's a function for everything. So we have got a function called pack that does some magic with the counter to turn it into the right format for something called hash HMAC. So we have an HMAC calculator built into PHP. We want SHA1 because that's the type of HMAC we need. Pass in the bin counter, binary format, sorry, a binary representation of our counter number. Pass in the secret. Have to pass true because it's one of those things where they chose the default round the wrong way. You know how that happens when you don't want to break BC? So you always have to put an extra parameter on the end and you always have to set it because otherwise it's insecure. It's one of those. Always set true for the last parameter. And that gives us our hash. OXOF to do our find the last 4 bits. Gives us our offset. And then it is a simple bit of binary maths. We're just bit shifting. So if you did C, then this would look really, really common. You'd know exactly what's going on. It's just some masking followed by bit shifting to put things into the right order. And then we can convert it to decimal and we're done. So you can write a HMAC OTP algorithm in PHP really, really trivially. It's good, isn't it? It's interesting. I find this interesting. You lot are just glazed over, but I find this really interesting. I love this algorithm. It's really clever. I'm amazed someone came up with it. What's really nice about it is that every time you change that number, every time you change the counter, the number significantly changes. So there's no concept of being able to guess the next number if you know the previous counter, etc. There is one problem. It's a little gizmo that you press a button on. Humans, we like to play with things, don't we? So we press that button a few times, and we press it a few more times, because it's fun. We give it to our child, and they press it another 100 times. The problem with a simple counter system is working out what number on the counter you are on the server compared to the number on the gizmo. So last time we logged in, we were at counter number 32, for instance. We assumed that the next time we get the number, it'll be counter number 33. In practice, it will never be number 33. Realistically, you'll have pressed the button a few times because, oh, I get the number up. And then it goes blank before you finish typing it in. So you press the button again, so you can type it in again. So what we do as the algorithm is we check our the last counter number that we agreed on, that actually succeeded, and then we increment up from there until we find the number that the user typed in. So there is actually a window of attack opportunity there. So you've got to be aware of that. And how far you look ahead determines how much risk you are prepared to cope with. Generally, people put it in the region of 200 to 400-ish. That's recommended by the RFC. So you look up to about 400 max. That's a lot of clicking that button by your baby's brother. If you can't find the number, you have to do a resync. And the way you do a resync is you get the user to type in one number, they press the button, and then they type in the next number. So you have two consecutive numbers. And then you just go on and on and on and on and on until you find it. And you give up eventually. If you get to something like 5,000, you still haven't found those two consecutive numbers, you ship them a new key. This is why those hardware things are expensive. But there's no clock in them, so it has to be done this way. The app doesn't work like that. The app uses a different algorithm. OTP. T for time-based. The nice thing about an app is that it's a phone more often than not, and the phone has got a clock in it. We have to agree what the time is between ourselves, our app, and our server. So one reason why you'll find that your Google Authenticator code doesn't work with your website is that the clock is wrong on your phone. So be aware of that. If your clock is out significantly on your phone, then you will not be able to use it for 2FA. You have to be within a minute of the real time in order for 2FA to work with your phone. Because that's how the algorithm works. Again, we have a shared secret. So us and the phone agree on a magic password. And we have a counter, which is the current time. And what we actually do is we bin the current time into 30-second blocks, which is why Google Authenticator times out every 30 seconds, because that's what we bin our counter to. That is only a recommendation in the RFC. You can change your bin number to whatever size you want. I've never seen anyone change it from 30 seconds. Everyone uses 30 seconds. If you want to read up on this one, it's 6238, the RFC number. I'm one of those few people that actually don't mind reading RFCs, and that one's not a bad one. It's relatively easy to understand. The reason it is really easy to understand is it doesn't say very much. And the reason it doesn't say very much is that it is a simple enhancement to OTP, sorry. All we do is we use the time to work out the counter number. And then we just plug it into the algorithm we've already looked at. So we collect the current time. That's obviously the number of seconds since January the 1st, 1970. Truncate it to the 30-second boundary. So always on the 30-second boundary. Gives you a new number. Take our current secret, push it into the HMAC OTP algorithm. So as you can imagine, the code is really trivial to write one of those. All you have to do is use the floor command and divide the time by 30. So when I say round time down to the period boundary, I simply mean divide by 30 and round. It's really, really trivial. Yep.
So should that be GM time to get the GMT time?
It should be, but because I always set my service to UTC, it makes no difference whatsoever. And anyone who doesn't set their service to UTC deserves shooting anyway. How do you guys cope if you don't do that? Whatever. So yeah, we do that. Although I've shown you some code for implementing this, don't use that code. I mean, it's my code, so it's okay, but don't use that code. Use a library. This is the way we do things in the world. We use Composer, and there's a nice project from the Sonata project people called Google Authenticator. use that. It's really, really easy to use. Generate your secret, because again, you just need some sort of random phrase for our secret. So let the system generate a random phrase for you, random set of characters. And then you can get a QR code, because the way we want to transfer that secret to the phone is to avoid someone having to type it in. Users don't like typing in a long string of characters. They're not very good at it. They get it wrong. So the way we do this is we generate a QR code, use a camera on the phone to read the QR code, and convert that into, the secret is embedded in the QR code, get it into the app that way. So the Google Authenticator library will generate us a QR code for the secret. That's quite convenient. Saves us having to do it ourselves. And then there's a handy method called check code for testing that the number is correct. So it's completely a time-based OTP algorithm. So here's what we need to do. We need to register the authenticator with our website. And then we need to check that code when we log in. So there's 2 stages to setting up this on your particular website. So how are we going to do it? The user is going to enable 2FA on their account. When they do that, we're going to generate the secret key, and we're going to present the QR code. The user is going to add it to their app. So they're going to use the phone QR code, it'll put it into the Google Authenticator for them. And then they are going to type in the next code they see back into our website, because that's how much we trust them to do this right. I.e., not at all. We will then check that code, and if they got the code right, i.e. we agree with them, then we shall store the fact that they've enabled 2FA, store the secret into the database against their record. That's the process you go through in order to register a 2FA app onto a given user's account. Is that fairly clear? Code looks something like this. It's not particularly complicated. This is slim code because I write a lot of slim code. Literally write a lot of slim code. I write for slim code, and I actually build the framework. Remarkably simple. We instantiate the authenticator library, generate our secret, there's our QR code, and then we render it to some sort of web page. I'm not an HTML person. Anyone who's seen my websites knows this to be true. Here's some simple HTML where we're going to echo out that QR code URL as an image. We're also going to tell them the code in case their particular app doesn't support QR codes because it's such an old Nokia or something. And maybe it's a Windows Phone thing, who knows. And then we're going to put a form on the website so that they can confirm the number back to us. And we get this wonderfully well-designed website thanks to Bootstrap. We've all seen stuff that looks like this when we've registered. And then we have to handle the post. So we get the post in, we grab the secret from the session because we have to store it somewhere whilst we're going through this process. Grab the code from the form on line 3. Instantiate our authenticator again, and then we call that check code method on line 6. And it'll be the true or false. If it's true, we're going to store it to the database, and I didn't bother putting that code in because it's quite boring, and you are more than capable of writing a website that stores something to a database. If it fails, we're going to throw some sort of error and they can try again. That's it. That's all the registration is. It's not that much code to do it nice and reliably. Of course, you'll design it a bit better than this. Login in process looks something like this. Once we have logged in, so we have to enter our username and password, we can test whether they are 2FA enabled or not. So is that user 2FA enabled? If they are, we prompt them for the code. The user will enter the code. I'm not going to verify if they don't. We will generate our own copy of the 2FA code and we will compare the two. If we agree, we let them onto the website. Again, not a particularly complicated thing to do. The code looks remarkably simple as well. We have a form with the grand total of one input field. These are my kind of forms. I like forms with only one text field. You can't get them wrong. And it looks something like that. Enter your code here and press the submit button. And then we have to deal with getting the code back in, and we have to process it. So again, we drag the user that has logged in but isn't really logged in yet. So we've already got their username and password. We pulled them out of the database to determine if they are 2FA enabled. We store that into the session so that we've got that information, but they're not a logged in user yet. So I use the key user in progress. So it reminds me that this isn't a really logged in user yet. Grab the secret from the user, get the code from the form, do the check code thing again. If we succeeded, we redirect, and having stored the user into whatever parameter we store in the session that represents our user. If we failed, try again. That's it. That's all you need to do from 2FA. I don't know about you, but I hate doing this on websites. I do it because I don't want my website, my web account to get compromised. So I've got 2FA on every website that will let me do it. But personally, I intensely dislike having to keep getting my phone out and looking it up and whatnot. So if you're going to round this out and put it on a production website, consider rounding out the solution. First things you need to do, consider preventing brute force attacks. There's only 6 digits there. Computers can submit post forms really quickly. They've already compromised the user's password, so they've already got through the login form, and now they've got a little computer there that's sending out the 2FA code much, much faster than that. If someone tries the 2FA code 1,000 times in a second, or however fast your website can actually respond, because I appreciate some frameworks are slower than others. Did I mention I do Slim? However fast it is, there is too many attempts to get the code correct. You probably don't want to let someone try more than 3 or 4 times before we kick them out for 10 minutes or something. Think about that. It's easy to automate this bit with any competent HTTP client. If you're going to let me on your website, you want me as a customer, please put a remember this browser feature on that form. If I get it right, allow me to click the remember that password, remember that browser feature. My laptop over there is encrypted at the disk. I'm pretty confident that if my laptop gets compromised and the encryption on the hard drive gets compromised, then the last thing I care about is that they can get into your website with my account. That's not going to be my problem. So I'm quite happy for my website to know and not need, my laptop to not need to have to enter that 2FA passcode every time. So it's really worth considering doing that for the average user in their home system. You also need to handle the situation that far too many people drop their phone down the toilet. How does that happen? I have no idea how that happens.
My phone for 2FA. Could you keep...
Well, seriously, there are lots of reasons why you end up changing your phone, losing your phone, buying a new phone, getting it confiscated by the TSA, whatever it might be. Your phone will get changed. When your phone is changed, you need to have a solution to allow the users to get back in. The most common way is to have some sort of secret passcode that you give them when they register, and then they put that somewhere safe, like a sticky note on their keyboard or something. Who knows what they do with it? Personally, I put them into my password manager. If you want to look at the code for this particular example here, github.com/slim2fa shows all that code working. And that's all there is. That is all there is to it. It's remarkably simple. There is absolutely no excuse for you not to have 2FA on your website. If you're using Drupal, Joomla, WordPress, anything like that, there's a plugin already built. Just turn it on. Okay? So that's how all the standard app-based 2FA password systems work. Last thing I want to cover is hardware-based ones on the magic of YubiKey. Has everyone here heard of YubiKey? Some people. YubiKey is quite clever. It's a little gizmo that you plug into your USB port on your computer and tap the button and it magically sorts out the 2FA for you. In practice, all it actually is another keyboard and it just types some characters into a form field. It doesn't do much in reality, but it looks quite cool. And it's a gizmo that you keep on you. They're quite clever. That button is a capacitive one, so don't wear gloves at the same time. So it took me ages to work that one out. Because it pushes, it clicks. My one clicks slightly, but it's not the click, it's capacitive. When you click that button, a string that long gets entered into that input field. So this isn't that 6-digit number anymore, it's a massively long string. Most of that string, well, not most of the string, the first part of that string is a common public key, public ID. So each YubiKey has got a unique number, and every time you press the button, so here I've pressed the button 3 times, the first bit, as you can see, is common because it's my public ID. So you now know the public ID to my YubiKey. That's okay, because every website that I've used my YubiKey on knows it as well. And then the rest of the number is the unique code, so it's significantly longer than 6 digits. It's actually made up of a 6-byte private identity field, counter, a timer field, a random number, and there's a CRC checksum in there as well, so the algorithm can kick it out fairly quickly if it needs to. Again, we need to code it up. Again, we're going to use Composer. An interesting thing about YubiKey is that that is not the official library. There is an official library on the YubiKey website for PHP. It uses pair. Enigma's doesn't. Enigma's uses guzzle. Guess which one we're going to be using? I don't think I've used pair in years. No, certainly not for a new build. Sorry? That was not a new build. At least I don't think that was a new build, because if that was a new build, we have to discuss and do some more consultancy somewhere. Enigma's YubiKey library works basically the same way as the 2FA library we use for Google Authenticator. It's the same basic idea. We have some sort of class, it's called validate in this case. And we call check rather than check code. And we pass in the post string and the YubiKey validator goes and does its work. The only thing you need to know about the YubiKey validation is it goes and hits their servers. So the nice thing about the time-based OTP system is that it's all done locally. You don't actually need an internet connection for it, but you will need an internet connection for this to work. Of course, you have an internet connection. It's a website. The user is just posted onto your website. Therefore, you had an internet connection to receive the key in the first place. So that's not a particularly big problem, unless, of course, their servers are down, in which case you host. So be aware of that. Again, like the Google Authenticator one, if you're using Drupal, WordPress, Joomla, or one of the big CMSs, just add the plugin. Joomla and Drupal are particularly good at this because you can enable multiple Authenticator plugins simultaneously. So you can allow your users to pick between YubiKey and Google Authenticator, or even have both if they want to on their account, and it will just work for them. So it's quite a nice implementation. And one of the bigger reasons for considering using one of the bigger CMSs, that you get all this stuff without having to code it up yourself. And that's all there is to it. You now know all you need to know in order to implement 2FA on your website. You have no excuse not to do it. I appreciate that your product managers are going to get a little bit queasy about making things a bit harder for your users. But if there's an administrative system in your applications anywhere, there is genuinely no excuse not to have 2FA on it. Thank you. Right, has anyone got any questions about that? Yep.
YubiKey is a third-party service. What happens if their database gets compromised? Does that mean every single YubiKey is going to be invalid or just be compromised?
I don't know. I would think so, yes. I don't know. But if you think, I think at the end of the day, it works remarkably similar to the time-based OTP. I think it works the same basic idea, but the algorithm is different. So if they get completely and utterly compromised, then their algorithm is known, and all the secrets are known. At which point you need to change the secrets. I'm guessing, I don't know, I would guess that the YubiKey is flashable. Oh, that's interesting. In that case, I would throw it away. That would be my choice at that point. If YubiKey are completely compromised, that the secret becomes known, then it's useless. Assuming that you trust them enough not to lose the Nets database. Or you discover that they algorithmically create the secrets. If they do that, then whoever has hacked it before can predict the secrets in the future. So at which point I would definitely throw it away. Your guess is as good as mine at that point. I genuinely don't know. One of the reasons I quite like the Google Authenticator solution is that you can just re-authenticate it. You know, if you lose your phone or whatever, or whatever happens to your 2FA app, and you accidentally delete the Google Authenticator app, you can start it up again and just re-register, and you get a new secret. So as long as that secret is generated fairly randomly, then you're fine.
Could you use something like random look, or does it have to do, especially with Google Authenticator, if you need a specific?
No, the secret can literally be whatever you like. I've tried it with a secret of test, and it will work. Don't. I think I made that clear. But yes, you can literally have any string of characters you like for the string. So yeah, you're going to use randomlib or some sort of random generator to do it. Probably a cryptographically secure one, because you don't have to generate these frequently, so it doesn't matter that they take a little bit of time. So yeah, I would use a cryptographically secure random number generator, personally. I don't. All I do is use the one in the library, because they've already done the thinking, they've read it up. I use whatever they give me. But yeah, in practice, the ability to change the secret trivially with the software-based solution is quite compelling. Yep.
Do you think we'll ever actually get this into mainstream? Because balancing effort and risk, given that we know that people will use the same passwords already and they won't install LastPass, the likelihood of them using this and staying with two-factor auth. I mean, I migrated phones, it was a nightmare, which made me move to Authy because it backs everything up in the cloud, which, yes, I know there's not, added that threat vector as well. Even I kind of experienced the pain of it. So until it's kind of integrated into the OS and browser, so we don't have to think about it anymore, I can't really see it being used.
Yeah, so the question was, do I think this will ever go mainstream? That is a really good question. Do you have a point about that?
I do, yes.
They've just integrated it into the latest version of Android. You now don't need the Google Authenticator app to log into Google services. It'll just pop up a little box on your phone that says, are you trying to log in? You just click OK. That's only works with Google at the moment, but there is an API coming.
Got a solution. And that sounds a lot like the way the Apple one works, which is quite nice. I think it has to be that sort of level of integration for it to ever become mainstream. Users just really prefer convenience over everything. It's an extremely difficult problem to solve. Fingerprint Touch ID solutions, I think, are more likely to become mainstream than two-factor authentication solutions. You just need a big enough motivation. So banks, for instance, can get away with it because there's a big motivation to be able to get at your money. That is quite a large motivation for most of us. We like our money. They've got our money. They want us to type in a 6-digit code. We'll type in a 6-digit code to get our number, to get our money out. So that's fine. AWS can do it. So any administrative task, you can start doing that. It would be nice if it was mandatory for things like the US government or the UK government, but clearly that's beyond the abilities of most politicians. Yeah, I don't know. I would like it to be more mainstream. So I think as a reasonable minimum, it should be on all administrative sites everywhere. I think it is not unreasonable that if you are given the permission to publish stuff onto your company's corporate website, then you should have some sensible amount of security on that. Anyone else got any views on how likely it is to go mainstream?
Well, what I would say, depending on what password manager you use and how much you trust it and how you sync your data and whether you trust the service that syncs that data, from version 6 onwards, one password will actually act as an OTP as well.
That is true.
So,
I have seen one password will do OTP now.
So you don't actually, then that is all just on the device and it will sync that OTP between your phone and everything. So even if you are only on a laptop, it will mimic a phone camera by giving you a little square which you move with your mouse over the QR code and it will read it in, and it will then one-time password within one password itself. So provided again, if you get a bit like if your laptop gets stolen, if your whatever Dropbox or iCloud or however you sync that gets compromised, you've got bigger problems. But you could actually have the whole solution in one, and that works with the browser plugins and everything for one password. So you don't have to worry about swapping phones or dropping it down the toilet or.
So my only view on that is that yeah, one password will do this for us, which is good because it does make it more likely to be mainstream. Except that most people don't use one password because that is too complicated for people. But the biggest the biggest problem is that your two-factor authentication has now become one-factor authentication.
Yes,
And that is a potential risk because at the moment it's my password manager for my password and my phone even with Authy, it is still two different systems. I also went to Auth incidentally when I changed from an iPhone 6 to an iPhone 7, did the iCloud backup restore, and you know what happened? Half of them disappeared. Half stayed, half disappeared. I have no idea why that happened. So yeah, I went to Authy as well for that reason. I quite like Authy, it seems fairly good. It's owned by the Twilio people, so they know communications fairly well, and they don't seem motivated to put advertising in it. We'll see. You had a comment?
Yes.
A question, even better.
What happens if you're the one whose database is compromised? Say you work for Yahoo, for instance.
So if I'm Adobe or Sony, there's so many big companies to choose, aren't there? Yeah, what happens if my database is compromised? Right, the most obvious thing that happens is that now that all the 2FA secrets are loose, and it isn't a standard algorithm, so hence anyone with a secret can generate the two-factor authentication password. So at which point, the 2FA password may as well not be there at all, and all that's limited is how quickly they can compromise those passwords in your database. So it's no different from a normal database breach.
There's no way you could hash the secrets, is there?
No. Well, yes, I mean, you could encrypt them. And then you've got the key somewhere else and you decrypt it and whatnot. But generally, when someone gets your database, they've also routed the rest of your web servers, and they've normally got the key by then as well, if you've done some actual encryption as opposed to hashing. It depends on the system you're building as to whether the additional steps are worth doing. Arguably, sometimes it is. I mean, if you're doing something that's really, really secure, then you're going to put more steps in place that will encrypt stuff up. Maybe your entire database is normally encrypted and gets decrypted in RAM and it's just really, really slow. Who knows? It depends on the system. I don't think most people do that. Most people will just, it's gone. You know, once you get a database breach, you've kind of lost. You need to reset everyone's password. You clear out all the secrets. They have to start again from scratch. So try not to lose your database, really. It's generally not a good move. PR-wise, it's terrible. I mean, you've got to be United or something like that, haven't you, to be worse? When is it inappropriate to use two-factor authentication? When your users can't use it. That's the only time I would not use it. If it is going to drastically affect your ability to get a sale, if you're a e-commerce type website, for instance, then that would be quite a good reason not to use it. If your demographics are the over 60s, for instance, that might be a reason not to use it. I don't know. The closest and most likely way this thing will ever go mainstream is if Facebook mandated it. Then you would discover an awful lot of people would learn how 2FA worked and would manage to use it remarkably quickly. It would have to be at that scale. But for the sort of stuff I do, if it's not going to impact the business in a measurable manner, then it's worth turning on. So it's always worth turning on for the administration systems. It's a toss-up for the front-end systems. You would generally make it optional. I don't think there are many websites out there that mandate 2FA. Even my bank doesn't mandate it. I can still log into my bank without a 2FA key, but I just can't pay people that I've not already paid before. So, yeah, assess your business needs. Okay, we're about 45 minutes in, so I think you're all bored of me, so we will stop there. If you thought this was fairly interesting, you learned something, or if you didn't learn anything, you were completely and utterly bored, please leave a feedback at joinedin B52C8, or just go to joinedin and find PHP Southwest near the top of the list. And I'd appreciate that, so thank you very much.